This is Clay Robinson from Precise Packaging Services. Today I'm going to talk about the need for proper orientation in designing child-resistant squeeze and turn type child-resistant closures. This particular one I'm using today as an example is a jigger cap on a mouthwash bottle, and you can see here that there are a lock 180 degrees apart. There are locks on the bottle, and those correspond with locks inside the cap. And I put a black mark on them so you can distinguish them from the centering ribs. There's some other features in there to help the cap get straight as it goes on the threads, but these two are to engage with the ones seen on the bottle here. So it's important that when these lock over, when you screw the cap down, and you can hear it as it pops over. You hear that snap as it pops over, and then the cap goes a little bit past that lock. Now, when that happens, if some things aren't designed or maintained properly in the molding processes of these two package components. For instance, if the height, or what we call the S dimension, is incorrect, if the bottle is, say it's shaved off a little, and you can actually simulate this by just sanding this surface down, the cap will go too far around, too far past the lock. And what that means is that by the time it backs up the threads, it may actually clear that lock on the bottle. So that's called timing. It must be timed properly. There are some other things that can also have an effect: the shape of the threads, profile of the threads, and how the cap and bottle interface. But what we can do, and what my company can do, is we would recommend that you use a gauge to determine that bottle, while it's being molded, is always properly oriented. The locks are in the proper position, and the way that can be done is with a gauge that simulates the cap, and you screw that on the bottle, and then the locks must come out in a certain range. Here you see that it's saying that anywhere between these marks, if the locks are located there, that they will work with the cap. So it is very important that during development and also during production that this be monitored, because there are things that can happen. A mold goes out for work, either the cap or the bottle mold, and components can go back in incorrectly. Things can happen that would cause you to have an orientation problem. Also, in designing and working with Type 1B closures, this squeeze and turn, what can also happen is the selection for the type of thread. Now, this particular bottle has a 6-pitch single turn of or single thread. It's a single start. There's only one thread start. Oftentimes you'll see a double start or even a triple start thread. What that can allow you to do is ramp up faster. So if you have a double start thread, that can exacerbate this problem, because the cap ramps up even faster and can actually clear the lock. Therefore, your timing requirements become even more important, that you just get past the lock, that when you screw it on, you break over the lock, but you don't go too far around, because if you go too far around, you're going to ramp up past it on the way back off. So that's kind of just an elementary discussion of lock design on child-resistant packages.